Okay, should I carry on?
How many people we have now? Yes, so Artem, should we? I guess we can start, Ahmed. It's fine.
Okay, so I will come back to this title later on. What do I mean by this dynamic padding search for and what is this wrapper feature selection technique in financial time series prediction? But first, just briefly, I would say that the same like in all other applications or other industries, the neural network has also been used extensively in financial time series predictions. In this project, we have focused on the feature selection aspect of neural networks. So normally on the bright side, it is handled within the training process. And this is like actually is a good point for the finance. And I will come later on why it is a good point. But also there is a widespread criticism in the financial literature that how relevant are the selected features that this neural network selects from usually a large set of possible features conducted. So we conducted the first literature review, which was about this feature selection techniques and neural networks in financial time series. We found that there are different authors that they did argue and showcase that neural networks do not always select the most relevant features within the financial applications. Also including different explanatory features do not always increase the prediction. In other words, for example, if we think that two features are explanatory or three and adding them together, like it will increase the prediction. This has not been proved working in different financial applications. There is also a finding that we have found, which is not related to neural network, but related to financial econometrics, which is, for example, that each financial market may require a different set of selected features. In simple words, that if we think of you as a customer who want to ask for a loan from a bank and you want to ask for 1 year loan, and another person who want to ask for a 1 month loan, then there is maybe that there are some types of information in the data set that are more relevant for you, that you are asking for 1 month, and the other type of information for 1 year. So we wanted to make we had our hypothesis, which was related to the time horizon. We said that maybe each time horizon prediction may require a different set of selected features. And the two questions that came to our mind is, can neural network select relevant features for each specific time horizon? If not, can other available feature selection techniques support it in selecting those features for each specific time horizon? And this has put us to the second literature review, which is related to the feature selection techniques. Of course, as I said, neural networks has the ability to select features. The question is, are they really relevant always? But other feature selection techniques that may support this neural network, we have the filter methods. The filter methods, they are conducted before the training process. So like Pearson correlation matrix or other types of matrices, or the random walk and such kind, to see how far they are correlated. We have the embedded. So we did not like this filter method. We don't think it's relevant because it's not embedded to the training of the neural network. So it's independent of the time horizon. We want a technique that's gonna look at the time horizon and then choose for us the features. So there are other techniques which is called the embedded methods. And here we have mostly the lasso and the ridge regression, which have been used widely in neural networks. But we have another third type of classes, which is the wrapper methods. And they work by evaluating a subset of features. We have the forward selection, the backward, the exhaustive, and the bidirectional. And this method got our attentions because they can evaluate a subset of features like separately. So we decided to go deeply into this wrapper method, and we did form our research questions as the two. Are neural networks able to select the relevant features according to the time horizon during the training process? And can embedding this wrapper feature selection method support these neural networks in selecting them? And and can this wrapper feature selection methods outperform other traditional embedded techniques like the lasso and the ridge regression technique? We want to embed these wrapper features, and we faced a problem actually. Embedding these wrapper techniques was not a straightforward process. It will require changing the input length of the neural network model every time the number of features selected changes. In other words, for example, if we select 4 features and then we want to select 3, then we have to change this architecture totally. Changing this architecture, as well as it will also change the number of the parameters and everything. So this will require rebuilding the architecture of the neural network for each experiment so that it fits the numbers of features selected. So for this, we said that a solution for this, if we combine a wrapping method with the padding, with the parallel computing, then we can use this, we can embed this wrapping method into the training process of neural network. And we call it the dynamic padding search. The dynamic padding search, what does it do? It's a kind of, if you have 8 features in your data set or 20 features, you are going to create a neural network with 20 input features. And for example, if you select this time 5 features and you want to ignore 3, then the other 3 will go with a padding of 0 so that they are ignored. So the DPS, what does it do? It's pads single or multiple inputs into an identical dimension, which enables to present how the individual feature works. When we have used this pattern, we were able to solve this challenge of changing the neural network architecture whenever we change the input features. Hence, we can experience these wrapping methods. And also, we have used the parallel computing so that we avoid overfitting. So these are the 3 techniques that we have used for this DPS. This is just schematic. I'm not going to go, I have already, I think, explained it. We just selected a random wrapping technique. We have selected the most exhaustive one. We could have used like the backward or the feed forward, but we just used the grid search. So the grid search, as you know, is evaluating all combination of possible solutions for a problem in order to find this optimal solution. Of course, in neural network, it seems irrelevant, but in finance, it is not always irrelevant because the data set of finance has its own specificities. It is made usually of numbers with low dimensions, as well as we have advances in the computation power. But as I said, it's just technique. We could have used the backward selection or other things. We have used the data set of an energy data set, and the predicted feature was the spot price prediction of electricity in Norway. So we have 8 different features, and we have used 5 different neural networks: ANN, CNN, RNN, GRU, and LSTM. Just simple architectures, and all of them, they had the same parameters, so that we put them into under the same experiment. I will not go deeply through this, just how we use this grid search. We are just going to look for all possible combinations, and then we did start like using the DPS. For example, if you select 1 feature, then the other one will go with an array of 0. If you select 2, then ignore the other one with an array of 0. This is why we fixed our architecture. The results were actually pretty good. The one in orange are the one actually where we are going to trust the neural network that it's gonna select the best features. And as you can see, it is not always the best. Actually, in all of them, none of them, the neural network was able to select the best features. And for example, on the left side, you can see for the 1 day, and the others, and on the right side, on the 7 days, we can see that this DPS was able to find the relevant features that are relevant for 1 day and for 7 days. It means that there are some information that are relevant according to the time horizon of our problem. For the GRU, it was the same remark. For the LSTM as well is the same. As we can see here, it is far away from reaching the best relevant feature. The neural network is not able to handle it by itself. Here it may seem the same, but it's not the same. Actually, these are different. Just like it was a question of Excel. But anyways, so our findings up to now is that the neural networks did not select the most relevant features. The relevant features for predicting different time horizon are not fixed. In other words, through the DPS, we showcase that there are information relevant for 1 day ahead and other relevant for 1 week ahead. And this one can bring us to the application that I told you. Should the banks look at the customers as the same that ask for a loan for 1 day as the same like they ask a loan for 1 month and 1 year? So they have to select different features according to the time horizon. Next, we have used this grid search just to showcase how we are going to use the DPS. We want to use a less computation heavy techniques such as the backward or the bidirectional search. And we want also to compare the performance of the DPS of this that uses the wrapper technique against the other embedded technique like the lasso and the reach, and see if they can, if it can outperform them. Yes, and this application in finance I have already went through it. This is basically the project that we have been working on.
Yes, thank you very much, Ahmed. I mean, this is a really very nice and very exciting project. So do we have any questions to Ahmed? Any questions or comments, maybe from Mingta? Okay, Ahmed, can you go to the, I have one, I mean this, can you go to slide number 12?
Yes.
Yeah. I guess it would be nice in this slide if you can maybe find the minimum, maximum, and for example, some statistical way to present the data. I mean, this representation is nice, but maybe also you need to make it, I mean, the maximum, minimum, for example, mean value and right?
Standard deviation, that's true. We have to make it more academic representation, that's true.
Yeah. For example, mean value, maximum value. I mean, of course, we need to. I mean, this approach would be nice if we have. How do you call it? I mean, the difference between the range. If the range is big, it means that it will make some big difference. And this one, is it for training or for testing?
This is for testing. This is for testing.
For testing.
Yes. And actually, when we are, and you are actually right, we have to know what is the minimum and the maximum. And as you can see here, the difference is very big from 4.5 to 1.5. That's a very big, especially when we are speaking about electricity, because electricity is about a small, just an accuracy of 0.2 can make a big difference. So maybe in other applications, small difference is not a problem, but here it is problematic. So the higher the accuracy, the better.
Yes, I have also a question regarding normalization. For example, if you are normalizing your data between 0 and 1, for example.
Yes, we have already conducted the 0-1 normalization, and yes.
But in this case, Mingita, what will be the meaning of 0? Does this mean that we don't have? I mean, this input does not exist because 0 padding. When we use 0 padding, we have some inputs equal to 0. Does this mean that we don't have this input, or it's a 0 value?
Yes.
We give it as we give it a 0. It goes through an array of 0. It means a kind of ignoring it without changing the architecture.
Yeah. Yes, in this case, should we?
Yeah. Go ahead. Sorry.
Yes, this one. No, I'm just asking if we will use 0 padding and we will put all other inputs as zeros. Does this mean that it's a 0, or it means that this variable does not exist? It's not an input.
No, we just set the new dimensions as 0. So 0 is 0 means
no input.
Yes, means no input. But we keep the entire neural network.
Yes. So over here we have 6 over here. If we come over here to 2, the other 4 will go with an array of 0 instead of going with the real numbers.
Okay. I have a question. If I trained a model, for example, with 20 inputs, and sometime in the future I'm lacking some inputs from some customers, or some people when you ask people to fill in a form, for example, sometimes they don't answer all questions. Is it possible to build a neural network with the maximum number of inputs and skip some inputs in the future after training it did you check after training if we will use zero padding, if it will have some impact on the performance? So if I train the model, for example, for 20 inputs, and after training and in deployment in daily life, I have only 15, for example. So in this case, we can use zero padding because I have some missing values. Does this have some impact on the performance of the model? This lack of information in the deployment phase? Did you try to, I mean, do you think of, does it have any meaning if we need to test something like this?
This is very hard to answer because it depends on how valuable are the information that are missing. Do they have like a big weight on the performance of the model? But we can use the padding to ignore them. Yes, we can ignore them, like ignore the features that we did not receive information about. But to answer you to which extent will it affect the performance of the neural network, I think this is experimental based, like depending on the data set. So this is what comes to my mind.
Okay, and also I have a question. What is the activation function in the first layer is used here? Because if you will use zero padding, it means the input will be zero. So for example, if you are using hyperbolic tangent, for example, zero in this case, it will be something in the middle, right? I mean, they will need also to
no, because we have
reload.
Yeah, we use reload because we have bias, so the value will not always be zero.
Okay, this is fine. Yes. Yeah, this is correct. Okay, but I mean, this paper will be very, very good paper, in fact. So what venue you want to publish it? Because it's a more technical paper. It's not finance, in fact. So which journal you will go for?
We did not really because we still like want to. It's very hard to publish it like this because we still have to compare it with the lasso. But I don't know. Like we were thinking about finance, or we don't think it's finance. What do you think, Ibrahim?
I feel that it's. I mean, this topic, in fact, it's a hot topic because so I know that some people are working with a kind of for developing a neural network which is flexible, in fact. So it can work with a variable number of inputs, not fixed set of inputs, but they want to build a neural network which can handle, I mean, a different, I mean, I don't know if it is in the deployment or if it is at the training phase, but this one, it's technical. So it can go also for something related to neural network and something more technical, because I guess this information will be very, very important for people from area of neural network to, I mean, to read and to, because it will be very exciting. But I encourage you to speed up, I mean, testing, experimental, and try to focus on it for, I mean, submitting this work. It will be a very good paper.
Thank you for the encouragement. Like this is actually, yes, if we can, you have actually like just showed us another way of thinking of this paper. If we can think of it as an adjustable neural network that can be used in deployments, then we have to argue about the activation functions, that we have to pay attention to the activation function that should be used, something like this. Then we can discuss this maybe later on a meeting, online meeting, how we can argue about it and what are the conditions for this padding to work.
But please also try to maybe speed up writing the report, because maybe you are in 4 weeks away from a report. So I mean, for the course, please start writing. It should be a report like a paper, or like a paper report. So you can just recycle it again in publishing it later on. So
we have
did you start writing?
Yes, we have written quite an okay number of words. I wouldn't say, but it was customized according to the finance as a finance application. So this is what how we started like this literature review and how we did argue in this introduction.
Yes. Okay, thank you very much, Ahmed. And do you have any other questions from other people to Ahmed and Bingtal?
Can I add something?
Yes, please.
Yes, please.
I think it's a good idea to send it to IEEE Access because it's not finance, and maybe you haven't had a chance to submit to financial journals. They are very like mathematical point of view. But I think it's a good idea to submit it to IEEE Access because they are multidisciplinary, and I think they have a very rapid review up to 6 weeks. So it's a good idea to consider.
What is called?
IEEE Access.
Access.
IEEE Access. Okay.
The journal, and I think, and because they accept a variety of topics.
Yeah, interdisciplinary.
Yeah.
This is a very good idea also. And I guess you can get this open access fees, article processing charge from NTNU base. Maybe you can pay it from your PhD, for example, PhD budget.
Yeah.
We can. Yeah. I think maybe it's a good direction. We can actually start it as a technical paper and then showcase how it can be used. For example, we can use it in finance, and we can use it in this, what you have said, Ibrahim, that we can show use cases. But I think definitely you are right. It has to start as a technical paper and then show case to the reader where he can use it afterwards.
As a case study in finance. Yeah.
Yeah, with a case study, if you want to use it in finance, if you want to use it in other domain, then feel free. Yeah.
So the idea here, if you will go for IEEE Access, you can download the templates and you can write directly into the template of IEEE Access. So I mean, it will save time. So even in the part for the course, you can write it directly in the same template and submit it to the course. So later on, you don't waste time. You can just use the same report, maybe fine-tuning it and polishing and submitting it to the journal.
But we are very happy that you are okay with the project. So that's very nice to hear.
No, I guess this is very exciting idea, in fact, and it's hot topic, I guess, at the moment. So because people are tired from just fixed set of inputs, and they try to develop new types of neural network which can deal with a variable set of inputs. Yeah. Okay. So any other questions? Okay. Amir, do you have any questions? Okay.
Hi,
okay,
Ibrahim.
thank you very much. Yes,
thank you.
I've seen this nice presentation, and I think it is a good idea to publish. But before going for publication, I think they need to compare this with some state-of-the-art methods. And I just want to ask one question from Amin, that what is the reason when you train your neural network with the 1 day data and 7 days of data, then it outperforms in 1 day data, but not with the 7 days data. And also it's same with the GRU. So,
no, actually these are this is multi-time horizon. Don't look at this one data and don't compare it with this one. We were trying to find if, for example, you as a let's take it like this. If you as a customer, you want to ask for a loan of and you want to pay it tomorrow, and there is another person who want to ask for a loan but pay it next week, and we have different features, different information about you. In other words, that there are some types of information that are relevant for assessing you if you will be able to pay me back tomorrow. And for another person who want to take a loan and pay it next year, there is also a different type of information that may differ, that are more relevant to his status of paying back in 1 year. It's pure finance, it's called default.
So the one so the 1 day and the 7 day, it's not the window length. It's not the time dependence in the time series. For example, I'm using the last 7 days data for predicting tomorrow, or I'm using the last day for predicting tomorrow, for example, or today for predicting tomorrow. Is it because I can understand it like time span or the time window, which are used for predicting for future prediction?
No, it's not the time window at all. It's the future For example, I want to predict tomorrow what will happen, or I want to predict 7 days what will happen, or I want to predict 1 year what will happen. So the best one to predict 1 day, these are the features, and the best one to predict 7 days, these are the features.
So it's a green one. It's
the green one.
So I mean, it's the best.
The best, yeah. The green is the best for 7 days, and here the green is the best for 1 day.
Okay, because what is y-axis here in fact? Because I don't understand what axis is it accuracy or?
Yeah, it's the MSE. It's the MSE. Sorry, I wasn't clear about this graph.
Mean square error. Okay.
Yeah, the mean squared error. Yes, we have. This is the mean squared error for the accuracy. The loss functions, we have also used the mean squared error, but we have also experimented with the MIE and another loss function, but the MSE was the best here.
But you can convert it into accuracy. The lower the best. Yes.
Yes, the lowest the accuracy, the lowest the error. In time series in regression in time series, we use the MSE as a prediction for assessing how good is how accurate is our prediction.
I mean, you can also compare this approach with other methods like select the k-best, for example. What is the best? What is the most relevant set of features which can be used? So we need to compare this approach with other methods as well.
We have compared already with the Pearson, the Pearson, and 4 other methods. The Pearson, and they are all filter methods. And this is why we said the filter methods should not be are not a good method. Because why? For a simple reason that the filter methods like the Pearson, they allow you to see this before the training. So in other words, that I'm gonna say, okay, these are my best features. So for whatever, if I'm gonna predict 1 month or 1 day or 1 year, I will use them. And this is what we showcase that it is wrong, that you cannot conduct this feature selection independently of the training process. It should be embedded together. It's a kind of, the neural network has to see what is the output. It has to see, okay, we have 7 days, then let me try to find the information that are relevant for my output. And when you change for it the output, it has to see to find other relevant information.
Okay, but this approach also, is it practical for large data sets or deep neural network, for example? So imagine that the training process takes some days. So is it really to use for I mean for testing all those possible combinations, and is it practical or you need to search for?
Here we have used the grid search, but definitely it's the wrapper methods is not only about grid search. There is like the backward selection or the forward selection or the binomial, which are less computational heavy. We have used the most computational heavy, which is not pragmatic if we are speaking about big data sets, about big in finance, and we are speaking about big data. However, if we want to use less computation heavy technique, there is no problem because we are going to use the same technique, the padding, the DPS. The DPS is not only for the grid search. The DPS can be used for all the wrapper techniques. You just have to change that kind of combination over here. For example, let me show you over here. This one. Yes, this one. In the grid search, we have used this combination technique. This is how we showcase that our padding strategy it will be. If you want to use your another technique, then you have to change this this equation, but you are going to keep the same DPS, the same technique.
So it would be nice also to show here time, a table maybe for time. I mean, training time, testing time, and other things. I mean, training time is the most relevant in the same machine. So you are doing it in one machine. You can have also some information about time used for each combination, for example, features, for each set of features.
Yeah,
it would be nice to show time also, how much time it takes.
That's true. We will try to
maybe also it's it's a time and the memory and yes, time used and how much memory we need, how much computational time would be very useful.
Yeah. We will try to use like the other technique of wrapping, for example, the forward selection, which is less computation heavy, and I think it's more attractive for the reader, because to tell the reader that it is a grid search, they may think that it only works with the grid search. But what we want to show is a concept of padding and parallel computing and wrapping technique. So this is the concept, and we just showcase through grid search, but we can use it for other wrapping techniques. It doesn't matter.
Okay. Do you use also here dropout after some layers? They use, because maybe dropout will have some impact on computational time. You should not use it, in fact, right? Because you don't know what is the impact. Is it coming from DSP, DPS, dynamic? It's called dynamic padding.
Dynamic
DPS?
padding search, yeah, DPS. We called it. We just called it
Search.
DPS.
Oh, is it from DPS or is it from dropout? So people should be careful.
Yeah.
Yes, and because actually the financial data is pretty simple, and our neural network only comprises 2 layers.
Yes,
So,
we did not use the dropout. We just used like simple architectures, and they were all the same. The data set wasn't like huge, so that we have to make like an advanced architecture or a complicated one. This is just it was a very simple architecture.
But it will be nice to have also some to show the computational time for each iteration, for example, or each combination or each set of inputs. It will be nice also to see if this approach also has some impact on its own accuracy and as well on time. So it will be really very, very useful.
It was great.
Okay,
also, great work with Mengtao. Thank you, Mengtao.
Okay, thank you, Ami.
Okay, so thank you very much, Ahmed. Thank you very much, Mengtao. We can take maybe 5 minutes break and start back again at maybe 9:40. Is that fine?
Yes, thank you.
Thank you very much.